Hello, Legacy students. So today we're going to look at the rest of rate of change and slopes. This is a continuation of what you were learning in class, so you don't need to title your page new. This is still the same notes. So now we're actually going to look at the mathematical way of slope. So you're still going to need your notes, pen or a pencil, and you may need a calculator just to do some simple calculations. So how do you find a rate of change? And basically, what is a rate of change? Well, a rate of change shows the change between two quantities. You can find the rate of change by finding the change over the dependent variable over the change in the independent variable. Basically what this means, change in y over change in x. So basically subtract the two y values over subtract the two x values. So let's take a look at what that actually looks like. So I have this table, and it shows the distance a band marches over time. What is the rate of change, and what does it represent? So what I need to do is to find the y values, the change there, over the change in my x. So let's look over here. What's the change in my y values first? So how did 260 and 520 become that? Well, that is a change of 260, right? I added 260. Same here, I added 260. It looks like I added 260. So it goes up by a constant amount. So we know that this is a linear equation. So I know my y values, my change in y values is 260. Well, on this one, I gotta find the change in my x values, which notice is just going up by 1 each time. So I get 260 over 1, because that's the change in my x values. So my rate of change is 260. Well, what does that represent exactly? What that represents is they are marching 260 feet per minute. Because the change in the y value is for 1 minute. So we know that for every 1 minute, the band is going to march 260 feet extra. What if they give you a graph, but you need to find the actual slope? You're not just going to say, well, that's positive. I'm going to say, well, what's the actual slope? What you're going to do, you're going to start at the leftmost point you can find. That's a nice little point. And you're going to rise or go down to the right point. Then you're going to run to the right point. Remember, slope is your m value, which is rise over run. So let's rise over run. So I gotta, from here, let's go to this point right here. So I'm gonna rise first because I need to get up to that point, to the same level as that point. So I gotta rise 1, rise 2. So I'm rise 2. And then I gotta run to that point. So it's gonna take me 1 to get to there, right? From this point. So I went up 2 over 1. So my rise over my run, which simplified down is 2. So the slope of my line in that particular graph is 2. Let's find it on this one. So I'm going to start at my leftmost point here, and I need to, looks like it needs to fall. So let's fall. How many times am I going to fall? 1, 2, 3, 4, 5, 6, 7, 8. Looks like I need to fall 8. So fall is subtraction because you're going down. Now, how many is it going to take me to run over there? I'm going to run 1, 2, 3, 4, 5, 6, 7, 8. So I fell 8 and I ran 8. So I have a slope of -1. Because -8 divided by 8 is -1. But now, are we always going to want to have a graph? Heck no, it's going to take us forever. So what if they don't give you a graph? Then we need to use this formula that was created. y2 minus y1 over x2 minus x1. So the change in your y's over the change in your x's. Basically, that's all you need to remember. So let's find the slope between these 2 points, -3, 3 and -5, 4. So what I'm going to first do is I'm going to designate who's x1, who's y1, who's x2, and y2. That way I can just plug and chug. So I have y2 is 4, so I have m equals 4 minus my y1, which is 3. over x2, which is -5, and I'm subtracting my x1, which is -3. So I'm subtracting a -3. Well, my top is 4 minus 3, which is a +1, over, well, I got double negative, so those come positive. So I get -5 plus 3, which is -2. So this is technically -1/2. It's better to put that negative at the top so you see it. Sometimes it gets lost when you have it in the denominator of a fraction. So it looks a lot nicer when you have it with your numerator or sitting out in the front of the entire fraction. Let's try it one more. So I have -1, 3, and 2, -1, and I want to find the slope of this line. So again, I'm going to designate who's x1, who's y1, who's x2, who's y2. So my slope, remember, it's change in y's over change in x. So -1 minus 3 and x2 minus x1. No, does it matter who I make x1 and who I make x2? Actually, it doesn't. It's going to work out either way. So sometimes I try to do the easier math, sometimes I just go with it. Either or, you can make it either way. So your friend might do it a little differently than you. They might choose the second point to be the x1, y1. That doesn't matter. They will get the same answer as you ultimately. So let's figure out this slope. -1 minus 3, that's -4. 2 minus a -1, well, double negative again. So 2 plus 1, that's 3. So my slope is -4/3. Not too bad, right? And that's the end of this video. See you later, Savers.